Hello students, welcome back. Today we're going to be continuing with derivatives of trigonometric functions. Alright, so let's remember what kind of trigonometric functions are the most essential ones. Yeah, those are the following. So sine of x, cosine of x, tangent of x. Right, those are the three most important functions. And remember, what is tangent of x? It's sine of x over cosine of x. Alright, so for this, for example, for tangent, once we know what's going to be the derivative of sine of x and cosine of x, we will be able to find the tangent of x by using the quotient rule from the previous lesson. Okay, so let's go ahead and find the derivative of sine of x. So we're going to say that f of x is equal to sine of x. Okay, so we're going to be using the standard definition by the limit, right? So f prime of x is going to be equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so that's equal to, we plug in, we're going to have limit as h approaches 0 of sine of x plus h minus sine of x all over h. Well, there are not that much things we can do, right? To work out the sine of x here. So what do we have to do? What do we have to do? We have to remember, right? We have to remember the formula, right? The formula for the multiplication, right? Multiplication of the angles and the sines and cosines. So if we have the subtraction, in this case, we're able to transform it, right, into the multiplication version of it. So let's go ahead and recall that. So since we have sine of x plus h minus sine of x, by the trigonometric formula, we're going to have limit as h approaches 0 of 2 times sine of x plus essentially h minus x over 2 times cosine of x plus h plus x over 2. Okay, all over h. All right, so we have that too. So, well, let's go ahead and simplify it. So I'm going to move the 2 in front to the denominator. So we're going to have limit as h approaches 0 of, so here we're going to have, simplifying that, that's going to be sine of h over 2 times cosine. So it's going to be 2x plus h divided by 2, so it's going to be x plus h over 2 all over h over 2. Okay, perfect. So now, here is the key thing. We're going to have the limit of h approaches 0 of sine of h over 2 divided by h times cosine of x plus h over 2. So recall, this is a special limit, right? Sine of x over x as limit as x approaches 0. This one is equal to 1. So in our case, this is exactly what we're working with, right? But here, right, we have to, of course, use the limit loss first. So that's going to be limit of h approaches 0 of sine of h over 2 over h over 2 times limit as h approaches 0 of cosine of x plus h over 2. Okay, so by using the special limit, right, which we know, that one will become 1, and this becomes 1 times cosine of x plus 0, which is equal to cosine of x. So that means, right, that means that sine, right, derivative of sine of x is going to be equal to the cosine of x. So sine of x prime equal to cosine of x. Okay, perfect. Now we can use essentially, right? We can do essentially the same thing for the cosine, right? If we do the cosine, right, and I will leave that for you. Leave that for you. There is also another way to do it, but we can do a similar way, right? If we use the trigonometric function, but here we will get that dx of a cosine of x, that will be negative sine of x, right? I'll leave that to you to prove. But now we're gonna go ahead and move on to the tangent, right? So dx of tangent of x, right? So how do we prove that? Well, let's remember that dx, it's going to be tangent of x is the same thing as sine of x over cosine of x, right? So here we have to use the quotient rule from the previous lesson. Okay, so by the quotient rule, we're going to have sine of x prime times cosine of x minus sine of x times cosine of x prime all over cosine squared x. Okay, so that's equal to, so derivative of sine is going to be cosine of x times cosine of x minus sine of x times negative sine of x. Okay, all over cosine square x. So that's equal to, we can notice that we're going to have cosine square x plus sine square x all over cosine square x. Well, let's recall the trigonometry. By trigonometric identity, we have that cosine square x plus sine square x, it's equal to 1, right? We call it trigonometric identity. This is the most important identity in the entire trigonometry. Okay, so that means it becomes 1 over cosine square x. Well, let's also recall that 1 over cosine of x is equal to secant of x. So that will end up being secant square of x. Right, so that means our equation for tangent becomes the following, right? So the derivative of tangent is going to be secant square x. Well, now let's go ahead and make a table. Make a table for the trigonometric functions. So here is our table, right? And of course, try it as an exercise. Try to prove that the secant is secant x times tangent x. Cosecant is negative cosecant x times cotangent x. And cotangent is negative cosecant squared. And recall that cosecant of x is equal to 1 over sine x. Secant we already know, and cotangent of x is going to be cosine of x over sine of x. Right? You can also use trigonometric identity for that. All right, so in the next lesson, we will do the chain rule.